Hello, this is video 6 for Interim 3 Math 8 grade at Mercer Middle School. This standard has to do with understanding that a function is a rule that assigns each input exactly one output. So first of all, let's briefly talk about what a function is. So a function shows a relationship between x values and y values, inputs and outputs, that has a pattern or a rule or some way of finding an output for an input and not having multiple outputs for one input. The example you guys talked about in class was a vending machine, for example, has a bunch of buttons here, and depending on what button you press, you get a certain type of drink. You could have Coke, and every time you press Coke, you get a Coke. So inputs are the buttons, outputs are the drink itself. If every time you press Dr. Pepper, you get Dr. Pepper, and every time you press water, you get water. But if this was not a function, it would mean that if you pressed Coke, you would not get a Coke. The next time you pressed Coke, you did get a Coke, which means there's not a real predictable rule for what happens every time you have a certain input. It'd be okay, though, if every single one of these was Cokes. So, for example, if I look at the table, I could have a input of 1 gets an output of 3, an input of 2 gets an output of 6, an input of 4 gives an output of 12. That's a fairly simple function. This function says multiply x by 3 and you get y value. So that would be y equals 3 multiplied by x. But let's say that I said I put in 4 for my function and this time I get out 10. Well, not only would the function not be multiplying x by 3, but look, I got an input of 4 and an output of 12, input of 4, output of 10. That's not a function. Each input of 4 needs to have the same output of 12 in order for there to be a function rule that was happening. So this would not be a function. This would be a function. I could get input of 2 gives an output of 6, an input of 3 gives an output of 6, an input of 4 gives an output of 6. That's perfectly fine because the function says whatever x is, y is always going to be 6. So that's a perfectly fine function. That is a function. Yes, function. Every input has its own unique output. So let's look at these. Consider the function represented by the following table of values. Which function below could have produced the values in this table? So I got to look at this table. There's a couple ways I could approach this problem. I could check every single one of these equations or these functions to see if it matches the pattern I see in this table, or I could work from the table to write a function rule and then just match it to one of these. So let's start from there. I see that when x is 0, y is 2. So if this was a linear function, that would mean I have a y-intercept of 2. Y equals some slope multiplied by x plus 2. And looking at all these, y equals mx plus b, y equals mx plus b, same. These are all linear functions. So that tells me this definitely is linear. It's just which linear function would it be? So I already can look at this and say, well, there's going to be some slope, some change in y over change in x, some change in this table as x increases. That's something. I don't know it yet. But I do know that the y-intercept is 2. Well, look at this one. Y equals mx plus b. Well, look, that's not the same. This has a y-intercept of negative 14. This is a y-intercept of 2 is what this table represents, so it cannot be a. This one has a y-intercept of positive 2. This one has a y-intercept of negative 22, so no, it's not c. And this one has a y-intercept of 2. So it's one of these. It's either b or d. Now let's actually find my slope, or my rate of change. So as x increases by 1, from negative 4 to negative 3 is an increase of 1. From negative 10 to negative 7, that's an increase of 3. Again, I increase by 1. Negative 7 to negative 4, I'm getting closer to 0, so I'm increasing by 3 again. Plus 1, also increasing by 3. And plus 1, also increasing by 3. So look at that. Every single change in y over change in x is 3 over 1. So my slope must be 3. And look, I actually put it right in here. Y equals 3x plus 2. That was a mistake, so I'm actually going to erase that. But my slope would be 3. And so my equation would be y equals 3x plus 2. Well, this one has a negative slope. Negative 3 is my slope. This table is not decreasing in value as the x's increase, so it's not that one. So I'm left with D. Now there is another way you could have done this. Another way you can check if a table of values really matches an equation is to see if the solutions, remember these are all solutions, x is -3 making y -7, that's a solution to this function rule. So I can check this function. When y was -7, x was -3. Let's see if that's true. -7 equals -9 plus 2. What's -9 plus 2? It's -7. Hey, it worked. I could check every other value in this table. When x is 0 times 3 is 0 plus 2 is y. Hey, that worked. When x is -1 times 3 is -3 plus 2 is -1, that solution worked. When x is -2, that makes -6 plus 2 is -4, that solution worked. Try this last one. 3 times -4 is 12, plus 2 is -10. That solution also worked. So every single one of these solutions, x and y values, makes my equation true. And it wouldn't make all the rest of them true. I'll show you one example and then we'll move on. Let's take a look at this one. When, let's use this simple example of -1. When y is -1, x is also -1. That solution worked for this function rule, but watch what happens on this one. -3 times -1 is 3, plus 2 is 5. -1 does not equal 5. So that function rule is not true for every single one of these solutions. So a couple different ways you could do that. Question part 6, C. Circle which of the following relationships below represent a function. Remember, a function means every input has to have a unique output. So that means that if I were to look at a graph, this would be a function, that'd be a linear function. This would be or a proportional function as well. This would be a function because every input, for example x, this x has only one y. There's only one point that has that x value. This x value has only one y value that goes with it, only one point. But this would not be a function. First of all, that's a mess because it circles back on itself. Look what happens if I find this x value right here. That y value is negative and that y value is positive. So that one x value, let's say this was a 2, that x value of 2 has an output of approximately -2, and it also, that x value of 2, also has an approximate y value of 3. Well, that x value does not have a unique y value. Each input does not have a unique output. So that's what I'm looking for when I'm looking at all of these tables. So on this first one, the table shows the age in years and weight in pounds of dogs. So I have age and weight. So I have a 3-year-old dog that weighs 30 pounds, a 4-year-old dog that weighs 38 pounds, but I have another 4-year-old dog and it does not weigh the same as the other 4-year-old dog. That means that that age is not a predictor of weight. There's not a perfect rule here. A 4-year-old dog does not always weigh 38 pounds. So that is not a function. There's not a rule I can apply to that. So because of this right here, the x value of 4 does not have a unique output. So this is not a function. It's a circle which relationships below represent a function. So this is not a function. Not a function. So I'm not going to circle that one. I crossed it off. The set of ordered pairs, 518, 522, 528, 5, -8. An x value of 5 gives an output of 18. An x value of 5 gives an output of 22. No, that's definitely not a function. Actually, every single one of these values shows it's not a function. If that was on a graph, x value of 5 has a y value of 18. X value of 5 has a y value of 22. X value of 5 has a y value of 24. X value of 5 has a y value of -8. I mean, every single one of these points has the same input but multiple different outputs. That is not a function. The table below represents the number of weeks, x, that you have this amount of money in savings. 0 weeks, I had $40. I started with $40. 2 weeks later, I had $45. 3 weeks later, I still had $45. 4 weeks later, I have $60. Now that's perfectly fine. That is a function. Because I have 0 weeks, I start with $40. 1 week, 2 weeks later, I increased my amount of money to $45. 3 weeks later, well, I still have 45. 4 weeks later, I have 60. Well, that's not breaking any of our rules of functions. Every input, every x value, 0, 2, 3, and 4, has a unique output. If I had this, if 3 weeks had 2 different amounts of money, that wouldn't make any sense, would it? I can't have 2 different amounts of money in my bank account at the same time. If I have, $45 in my bank account, that is all. That's the only amount of money that would make sense for me to have. I can't have 2 different realities at the same time. So that one is a function. Every input has a unique output. Part D, I wrote earlier on this, so I'm going to erase it just so you can keep track of what I'm talking about. Y equals 5.80x. So that's saying that if x was 0, 5.8 times 0 is 0. If x was 1, 5.8 times 1 is 10, 11.6. If x was 2, if x was 3. Notice every single time, as my x's increase, my y's also increase. So that means that there's no possible way I could put in an x value and get 2 different y values, because that number multiplied by 5.8 is always going to be that same number. So I'm not going to get 2 different outputs for an input here. So this is a function. Another way to know it's a function is this is just a proportional relationship. Y equals kx from 7th grade. So that means that that's just going to look like a line. So that is a function. If you see something in this form, yes, it's a function because it's proportional. If you see something in this form, well, yes, it's a function because it's linear. So we don't have to think any further about it. Last one, this graph below. Well, if I were to make a table out of this, I would quickly see that an x value of 1 has an output of 1, but it also has an output of negative 1. An x value of 4 has an output of 2, but it also has an output of negative 2. So we also call that the vertical line test. This x value here, 4, has 2 different outputs, so that is not a function. So we're going to say not a function. If you need any further help with this standard, please go into Khan Academy and search for 8F 1, 3, and 5. Essentially just search for the function standards for 8th grade and go over the videos they have on functions there.